Hello, and welcome back to Class Time, your daily classroom for CSEC students. Watch this lesson in real time on Television Jamaica's YouTube channel or One Spot Media.
In today's mathematics lesson, we will be focusing on measurement, distance, time, and speed. I am Shadeen Cassie.
And I am Nikisha Hardy. Let's get started. So, as was said, we're looking at speed, time, and distance. So therefore, the objective for today is to solve problems involving time, distance, and speed.
In our everyday life, speed, time, and distance plays key role in our daily activities. As you can see, if we're traveling, time, speed, and distance is very important. If we're walking, if we're taking on a ship, or if we're going to take the airplane.
Okay.
Yes.
Also, playing catch. When we're running around, there is speed, because we don't want to be caught.
No, you don't want to go too slow.
No.
Right?
Right. And also, there's a distance that you cover when you run and also during a particular period of time.
Good.
We also interact with speed, time, and distance in sports.
Right. So we see the fastest man there, Usain.
Yes.
His time, fastest time, and it is based on the distance that was being covered.
Yes.
There's also the long jump, and for what?
I think this is maybe javelin or so.
Yeah.
All right, so speed, time, and distance is very integral. We don't even realize that these factors are coming into play, even with the water falling.
Yes, a part of nature, we see that speed, time,
and the distance that the water has fallen.
Yes.
All right, so seeing that speed, time, and distance is in everything that we do, think about a family trip. Okay, now we're going on a trip from Buff Bay to Montego Bay. And the journey is approximately 180 kilometers. Now, we want to reach in 2 hours. At what rate would we need to travel?
Okay, we don't want to go too slow,
No.
and we don't want to go too fast either.
With
so
the speed limit?
The speed, the rate, and the time will play. So you told me that you want to reach in 2 hours and you want to cover a distance of 180 kilometers.
Yes.
So the rate, at what rate will we travel?
So I am thinking that we could divide up the 180 kilometers in the hours.
Into smaller portions. So 2 hours.
Yes.
If we cut it into a half for 1 hour.
Yes.
Thinking about 90 kilometers. All right.
Yes. So that would be 180 divided by 2.
Good.
And that, as you said, would give us, that would mean what?
For every hour, we would cover a distance of 90 kilometers.
90 kilometers per hour.
Per hour. Yes.
Wow.
And that's our rate.
And that's our rate.
Yeah.
So, but we're going to be driving 90 kilometers every second of this hour with all the potholes and traffic.
And the corner and the traffic.
Yes.
We might encounter a vehicle that is going slower.
Right. So therefore, we wouldn't be going 90 all the time.
No.
But it just means that we do need to cover
90 kilometers within the first hour.
Within the first hour.
Yes.
So when we are going, the 90 kilometers per hour would be what? That would be our?
Average speed.
The average speed. So when I look at my speedometer in the car, what am I looking at?
You're looking at the instantaneous speed.
Okay, so that's the speed at that time.
Yes.
Awesome, because when I was coming in this morning with all the potholes and all the
big
trucks and all of the debris on the road, I wasn't driving
at 90.
At 90 or any one speed all the time coming in.
Right.
All right. So average speed per hour and instantaneous speed would be what our speedometer is showing us. All right, back to the family trip.
Yes.
Let's take another spin on it. What if we were traveling at 60 kilometers per hour? How long would it take?
So for every hour, we will cover 60 kilometers.
Okay, so the first hour would be 60.
And then the second hour would be 120.
Awesome.
And the third hour would be 180 kilometers.
So it therefore means that we would need 3 hours traveling at 60 kilometers per hour to reach to our destination. So it would therefore, time would therefore mean 180 divided by 60, the average speed, and that would give us 3 hours. Now some of the things, the concepts that came up in that scenario was distance.
Right, and distance is a numerical measure of how far apart objects or points are. It is a way of describing what it means for elements to be close to or far away from each other.
Okay. Also in the scenario, we spoke about speed.
Good.
And speed can be thought of as the rate at which an object covers distance during a given unit of time. Also, if speed of an object does not change during the motion, the object is traveling at constant speed, as we were talking with the 90 kilometers per hour. So there's no change during that motion.
Right.
And the average speed of an object tells you the average rate at which it covers the distance.
Yes.
Okay? Another concept that came out was?
Time. Time is the measured or measurable period during which an action, process, or condition exists or continues. It's the duration.
So that would be like the 2
How
hour,
long it lasts
or
for.
the 3 hours, or it could happen in a few minutes.
Right.
Depending on
Could
the
be
speed.
a half an hour,
Yes.
depending on the speed
Yes.
and how far.
And how far we're going. Awesome. So what if we wanted to, so just now we looked at calculating the time. What if we wanted to calculate the distance? We were not given the distance. We were told that we would have to go at an average speed of 90 kilometers per hour.
Right. And we wanted to use 2 hours.
Yes.
So we were given the speed, and I'm using S to represent speed.
Yes.
And we were given the time, and I'm using time, and we want to find distance.
Okay.
Right? So if we multiply 90 by 2, then we will get a total distance of
180,
kilometers,
which was mentioned in
the question there.
All right. So what if I wanted, I see you have distance equals speed multiplied by time. What
Right.
if I wanted to find time in this instead?
So we also discussed that to cover the same distance. Let me start out with the representation. That's D for distance.
Yes.
With a given speed, referring to the trip there from Montego Bay to Buff Bay,
Okay.
same 180 kilometers, and going at a speed of, say, 60 kilometers per hour, this would have given us 3 hours.
Okay.
So it will take us 3 hours. So in order to find the distance, what we did was to multiply the speed times the time. And in order to find the time, we're now dividing the distance by the speed.
And if we wanted to find the speed as we did?
Right. So for some persons who are more advanced and would have gotten the hang of this, then we can see that we could transpose the formula.
Definitely.
And get distance divided by
time. And that's what we did in the first instance. We
Right.
divided the 180
by the time
that was given, which was
so
2
it was
hours.
180, and we divided that
By
by
2.
2 hours.
Yes.
And we got an average speed of
Yeah.
90 kilometers
per hour. Awesome. But these are 3 different formulae that I need to remember.
Yes.
Wow, it's so much. However, we have found an efficient way using a triangle to help us to remember which formula to use to calculate which quantity.
Right.
Have you seen this triangle before? In science, more than likely, in physics. I remember using this triangle in physics class. So if we can use this to find any one quantity, whether distance, D for distance, S for speed, and T for time. And if you know two, because notice prior we had two quantities in the family trip. We had distance and we had time. So as long as you know two of the quantities, you can find the other quantity. Here we have speed being multiplied by time
To give us
the distance.
Yes.
So let's look at how we can use a triangle to help us so we don't have to remember all three.
This.
All right, so we want to find speed, so we would cover speed, and what we're left with would be distance divided by time. So we can use this line here as our dividing line,
Yes.
fraction bar. So it would be distance divided by time to give us speed. Now, if we wanted to find distance, we would cover,
Distance.
which would be the D, and what we're left with is
Speed multiplied by time.
by time. So it would therefore mean if we want to find time,
We would cover time, and then we'll see that time would be equal to distance divided by speed.
awesome. So this triangle is very useful so that we don't need to be trying to remember all of those formulas.
Yes.
All right, so let us use the formula since we don't have to
Now that we
remember
understand what we're doing, we can go and apply all of that.
in different situations.
Good. So a truck leaves Yalas, travels 150 kilometers to St. Anne at an average speed of 60 kilometers per hour. How long did the journey take? They say, how long did the journey take? They're asking us for the time, right? The how long, the duration, right?
True, true.
So what are we going to cover? We want to find the time, so we are going to cover time.
We would cover time, yes.
And we'll see that time is equal to distance divided by speed. We were given the distance to be 150 kilometers, and we are given the speed to be 60 kilometers per hour.
And when we divide,
the time is 2.5, and we know that time is measured in hours for this case.
yes. So that 0.5 hours would be 30 minutes.
Right.
Okay.
Half an hour.
Yes.
2.5 hours.
And you must, when you have calculated and gotten your answer, so notice we have our units. So that's very important in working questions with measurement. All right. So let's look at another situation. So we have a train traveling 555 miles at an average speed of 60 miles per hour. How long did the journey take?
Nikisha, if you notice the representation, we
Yes.
have MPH in this case. Before it was K/H.
Yes.
So it's a different representation, which was done in previous lessons, right? So it means the same as miles per hour, or if we were dealing with kilometers, then it would be kilometers per hour.
So this is 60 miles per hour.
Good.
All right.
And it asks us again, how long did the journey take?
So this we're looking at time.
And it is distance divided by speed, 555 divided by 60, and the time would be in 9.25 hours, which is the same as 9.25 hours.
Right. And 9.25 hours, quarter of an hour would be 15 minutes. Okay? All right, so let's see. This one says a windsurfer traveled 28 kilometers in 1 hour, 45 minutes. Calculate his speed. So this time we're trying to get speed. So it therefore means we're going to cover speed.
And we will see that speed is equal to distance divided by time.
Awesome.
Right. The distance there is 28 kilometers, and we're dividing that by 1 hour, 45 minutes. So I see you did some amount of conversion there.
Yes. So that 45 minutes is 0.75. All right. So which would be 3/4 of an hour, which would be 45 minutes. So when we do that division, we'd get 16 kilometers per hour. All right. So that's how fast the windsurfer would be traveling per hour, average speed at this point.
Yes.
All right. So here we have the last one.
A runner's average speed is 8 meters per second. How far does he run in 25 seconds?
So we're looking at distance.
Yes, we want to find the distance because it asks us how far.
How far?
Right.
Good.
So covering distance will show us that distance, to find the distance, it would be equal to the speed multiplied by the time.
And in this case, the speed is 8 miles per second, and the time is 25 seconds. So as we're seeing on our triangle, we're supposed to be multiplying these two quantities, which would give us a distance of 200 meters. All right, so remember our units. Okay. Now we have been talking about speed. What about velocity? Here we have two situations. An airplane is traveling 804 kilometers per hour. And also in green, another airplane is traveling eastward at a rate of 804 kilometers per hour. I seem like I said the same thing twice. Do you note any difference?
Let us examine it carefully. I'm seeing speed to be,
Speed being the same.
yes, and it's per hour.
Yes.
But then there is the word eastward. At a
Okay.
rate eastward.
Yes.
And then I'm not seeing it in the one on the left side.
In the orange.
So I guess the main difference there, everything else would have been similar, excepting that there is a direction that's given.
Eastward direction.
Yes.
Okay. So, based on that, we're seeing that once the direction is involved, we're talking about velocity.
Right.
But as long as we're going at just constant speed, no direction given, same direction or what,
Then we're talking about speed.
speed. So in that case, seeing that we have made that clarification, what is velocity? Velocity is defined as a vector which is measured at a rate of, measurement of the rate and direction, because vectors have direction and size. So in this case, we're looking, it has speed and direction. All right? So simply put, velocity is the speed at which something moves in a direction. Okay? For example, the speed of a car traveling north on a major freeway and the speed of a rocket launching into space can be both measured using velocity because they both have speed and direction.
Good.
All right, so let's test our knowledge.
All right, so here we have a list of situations. A storm is traveling 25 kilometers per hour eastward.
All right?
Amy moved the desk 34 centimeters to the left. I'm seeing direction.
Yes.
An airplane travels 1,260 kilometers from San Francisco northeast to Chicago in 3.5 hours or 3.5 hours, and I'm seeing direction again.
Yes.
Megan swims 110 meters towards the shore in 72 seconds. And it says towards the shore, so that shows us what direction she was heading in.
And they have speed as well.
Right. With all of these descriptions, would you say it is speed or velocity?
I want to make comparison with some other situations first before I make my decision.
Okay, good.
So here are some others. Jackson ran 5 kilometers in 24 minutes. Okay. Meaning Jackson is running okay, that happened in 24 minutes, but it didn't say in which direction.
No.
A train travels 90 kilometers in an hour. No direction. One walked 400 meters in 17.5 seconds. No direction. A hurricane travels 360 kilometers in 15 hours, and I'm not seeing any direction mentioned here in this situation. So, based on what we have said before, that we need speed and direction
to determine velocity.
Yes, we can conclude that the first list is velocity.
Right.
And therefore, these situations on the right here would be speed. Awesome. All right. All right. We
All
seem to be
right,
having some
so
technical
we need to
difficulties.
note that the importance is that the direction, you made mention of a vector,
Yes.
right? The vector has magnitude and direction. So, and that is what a velocity looks like. It can be represented as a vector because it gives size and direction.
Direction.
While the speed, an average speed, there's no direction in it.
Just
So
as-
whether you want to run up, down, sideways, it doesn't really matter. You're moving at a speed once there's some amount of movement. But if you're going in a left direction or in the right or
Yes.
eastward, north, south,
Yes.
then we consider velocity
Okay.
at that time.
Okay. Good. So we're going to take a quick break. We'll be back with more mathematics.
Welcome back to class time. If you're just joining us, we are looking at measurement, distance, time, and speed.
Okay.
So we are going to be moving now from speed and velocity, and we're going to be moving into acceleration.
All right. So just to refresh our memory on the velocity and speed, velocity measures speed and distance. We use velocity to measure speed and distance.
In a particular direction.
Right.
And speed is just distance.
Rate at which a distance is covered.
Right.
All right. So let's see if we're looking at, you're at a racetrack at Dover watching an exciting race. You notice that cars are traveling at high speed and they're going into curves, making curves and turns like in junction. I don't know how they do that so fast around those corners. They're covering at great speed, covering distance in a particular time.
Right. So once they actually start out, then
Yes.
they do not reduce their speed. So they start and the speed just keeps climbing.
Can you imagine their heart rate at that point?
I guess their heart rate is normal, but had it been us, then we would be freaking out, right?
Yes.
Yes.
So when they're going, you just mentioned that they're traveling at this speed and they don't slow. So when they're going around the curves and turns, is the speed
They still increasing their speed.
Wow. So the speed is not always constant.
All right. So what we really, in a motor car, we refer to the gas. You ever hear somebody say,
You
step
press
on
the
the gas?
Yes.
It's not really the gas. That the proper name is really the accelerator. It means that it allows the vehicle to start moving, right? And if we want the vehicle to stop, then we would have pressed on the accelerator. We actually use the brake.
Yes.
So once we start accelerating, then it means that we are increasing in speed.
Okay.
Yeah.
All right. So acceleration, therefore, is
when an object changes speed or velocity, because the car in this case moves in a particular direction, we call this acceleration. Acceleration is the rate at which velocity changes.
okay. Okay.
And if you notice, they are using velocity and not speed because we are moving in a particular direction.
Very
Right.
important. All
In
right.
order to calculate acceleration, then we divide the velocity by the time. Yes.
Okay. So, and that is very important in also to determine who.
Right. So one might say that the speed can be reduced. Yes, at some point they actually reduce in speed, and this is called deceleration.
Okay.
Deceleration is negative acceleration, or
So like when you step on the brake or you ease up off the accelerator.
right, you start the velocity starts reducing.
Okay.
So deceleration is the name for that.
Yes.
And deceleration is negative acceleration,
Okay.
or a decrease in velocity.
Okay. So, bearing this in mind, I have first situation on the board and we want to decide whether if this is acceleration or deceleration or if there's any. A box travels on a conveyor belt that is moving at a constant speed. So I'm visualizing the box going on the conveyor belt, and most times the conveyor belt is moving
In a particular
in a
direction.
particular direction.
Yes.
And it's at a particular speed, a constant speed. So is there any acceleration there? Is that acceleration?
Because the speed is constant,
Okay.
then it's no acceleration.
Okay. Now what
So
if
we are neither going up nor
not
down.
down? It's
So
just constant, steady,
Yes.
a steady speed. Okay. So if a car is traveling on a winding road, right, winding road, and we used to do winding road in Jamaica, and we're going at a speed of 60 kilometers, and I see some people go around the corners much faster than 60 kilometers. Many times I'm on the road, very skilled. I don't know if it's skilled or reckless. But they're going at 60 kilometers per hour, which is quite manageable in my
For
estimation.
some persons, yes. For some persons, yes.
Okay. So it says winding road. So you know we're going. I'm seeing change in direction.
Yes.
Even though we're going at a speed of 60, a constant speed of 60. But when I think about the winding road, I'm seeing direction
Yes.
changing. So that would be
Acceleration.
Awesome.
Catherine is at a stoplight. When the light turns red, she drives 45 kilometers per hour westward.
Okay.
So westward and the velocity there would suggest that there is an acceleration, right?
Okay. Because as you mentioned, direction was
Right.
mentioned. All right. And if she's at the stoplight, traffic light where she is,
Not moving.
not moving,
She's at a rest point.
yes.
Then there is no acceleration. She's not moving. Constant speed.
Okay.
Yeah.
Okay. All right. Now with this brings to mind the speed time graph. Now on the speed time graph, with any graph, we know we have the x and y axis. And we notice that on the x-axis, we have time on this, and we also have speed on the y-axis. And I also notice that the red line is labeled constant acceleration. And at that point, what is happening?
What is happening is that the movement, I won't say person or vehicle, whatever
Yes.
is moving,
Yes.
it keeps climbing
Yes.
in terms of velocity. So
Okay.
there's a direction showing that it is going upward, right? And it keeps moving.
At that speed.
Now, Nikisha, I also want to highlight that on the graph there is no negative at all.
Okay.
There is no negative, and I'm accustomed to my Cartesian plane where
We
there
have
is
both
the
positive
negative, yes,
and positive.
So why is that so?
Well, time, speed, we normally, as you mentioned before, you have negative acceleration. However, we give speed or acceleration positive.
Right.
Distance is not negative.
Yeah, we cannot have a negative distance.
Distance.
Once there is a movement, it is a positive
Positive
distance.
movement.
But they say negative acceleration because it shows direction.
Yes.
So the positive shows that you're going up. Once you're going down, then they use the negative to represent that, which is the same as the constant deceleration. So I'm just going to jump over to the constant. 'Cause
Okay.
You had
Okay.
explained to us the constant acceleration.
Okay.
Constant deceleration would be the opposite of what is happening with the constant
Acceleration.
acceleration. So the movement now is going down. That's where the negative will come in to show us the direction, right?
And the constant speed at the top where we have the apex there, right? Not the apex, this plateau, right, across here.
Yes.
What is happening there?
It could be that the person would have stopped.
Yes.
Or they would have been maintaining an average speed of
Okay.
whatever it be, but they are not moving any faster or any slower than that. We
Okay.
normally refer to it that they would have come to a stop.
Okay.
Yeah.
Okay. All right. So we would have been using, and before we go on any further, in terms of under the graph, so we have the green section as the graph that was created, right? So from this graph, we can calculate speed for different sections of the journey.
Yes.
We can also calculate time at different parts of the journey.
We can also find distance
Yes.
covered over different time too.
All right, so let's move to the next slide and see what's there.
Yeah.
Yes. So area under the speed time graph. Now your brother and sister are playing catch. They are running at a constant speed of 5 meters per second for 30 seconds. We want to know how far did they run. So how far suggests distance. right? And here we have our X and Y axis. X labeled with the time and the Y with the speed.
But we can go back. You said that we wanted to find how far, which refers to the distance. The triangle.
Yes.
We cover what? We're going to be covering
But
distance at the top,
Okay.
and we will be left with speed
Speed at-
multiplied by time. So in order to find the distance, we need to remember that we must multiply the speed by the time,
or special triangle.
or special triangle.
All right, but when I look at this shape here, notice so we did 5 multiplied by 30 give us 150 meters. So that would give us the area under that graph, which would be the shaded region, the area there. And notice that as we talk about area, and I'm looking at the diagram, I'm seeing a rectangle.
Yes, that's the geometric figure.
The geometric figure
that's
that is
highlighted there. And we know that in order to find the area of a rectangle, then what we need to do is to multiply the length by the width.
and that would give us the area under the graph, which would be the distance.
The total distance traveled.
The total distance traveled.
Yes.
Okay. All right, still looking at area under the speed time graph. So the area under the line on a speed time graph is equal to the distance traveled by the object. All right? So if the shape of the graph can be broken into simple geometric shapes, the total area under the line can be calculated by adding the areas of those shapes. In the previous slide, we saw a rectangle. And on this,
We are seeing, we could look at it that we are seeing just a trapezium.
Yes,
or a rectangle and a right angled triangle.
and we know how to find area of those two shapes.
Right. Nikisha, what I like about this is that we see area coming into play, and we know that area is the total amount of space occupied within a given boundary.
Right.
And also the geometric shapes. We have to have knowledge of what those properties are in order to apply what we know about area to finding the area, to come up with the total distance. So we are seeing the overlapping there with
We're using previous knowledge and bringing it into play currently to what we are learning now.
And this makes it simpler because
Yes.
if I don't remember how to find the area of a trapezium,
Yes.
then I can find the area of a rectangle, hoping that I remember.
We should remember that one.
Yes, as well as the area of
The right triangle.
the right triangle.
Awesome. So let's start by finding the area of the rectangle. So notice the area of the rectangle, length multiplied by width, which would be the time, the distance from 0 to that first line there would be 10 seconds, and the speed traveled would be 10 meters per second. So we multiply those two quantities and we get the area of that rectangle, which would be the distance traveled at that point, would be 100 meters.
Squared meters.
Square meters.
Yes.
And if we look at the triangle, the right triangle, applying the formula half base times height, notice that we have 18 subtract 10. Why is that?
We are taking away 10 or subtracting 10 because the total amount of time spent would have been 18.
Right.
And we want to find just a portion of that 18, which would be between 10 and 18. So in order to find that, we subtract 10 from 18.
And as we are focusing on the triangle only.
Yes.
So substituting those values, and we do half of 10 times 8, that would give us 40 square meters for the area of the triangle. So now we have the area of the triangle and the area of the rectangle. So if we want to find the total area, we would therefore add, and that would give us 140 square meters, which would be the total distance traveled.
Right.
Okay. So let's see if we can apply this knowledge to a question from CSEC. All right, so reading the question, the speed time graph below, not drawn to scale, shows a three-stage journey of a racing car over a period of 60 seconds. So let's first examine the graph.
Right, so the first stage is an acceleration. The second stage is constant speed there, whether the person is resting or they're just moving at a constant speed. And then the third stage is deceleration. For some questions, they referred to the journey out, the rest point, and then the return journey for some cases.
Okay.
Right, not saying that that's what is applied right here, but what we need to find now is a missing time.
Okay.
What amount of time was required to cover the first stage of the journey?
And we are told that during the first stage of the journey, the car increased its speed from 0 meters per second to 12 meters per second in that period of time, accelerating at 0.6 meters per second squared. So we need to find, as you said, that time period that was.
Right, and based on the graph, we are seeing that the acceleration given in the statement, and we
Yes.
know that acceleration means that we are moving in a particular direction, and we are going to be needing the velocity in order to find the time.
Okay.
Right.
So substituting acceleration, 0.6 as was stated in the question, and velocity,
12 meters per second, as stated in the question, then we can transpose in order to find the value.
X the subject.
Make X the subject.
So there would have 12 being divided by 0.6, which would make X being equal to 20. So that would be 20 seconds. All right? So the first stage of the journey would be 20 seconds. Continuing. So now we're at the second stage of the journey. What is a car? So the gradient of the what is the gradient of the graph during the second stage?
All right, we know that when the line is horizontal or vertical, we are seeing where geometry is taking part in this lesson. When the line is vertical or horizontal, then we consider the gradient to be zero.
Okay.
So the gradient of the graph during the second stage is 0. Now the next question is, what is the car doing during this stage?
So as we were looking at the previous graph example that we had, you mentioned that it could be resting, it could be just stopping, it could be traveling at a constant speed.
And in this case, the car is traveling at a constant speed of 12 meters per second during this time.
All right. What about the distance traveled?
I was going to say that, so we could say the driver is just cruising.
Cruising.
Looking,
okay.
sightseeing, and all those stuff during this time.
So at this point in time, is on the pedal, the gas pedal just resting there?
Yeah.
No increase, no decrease?
No.
All right. So the distance traveled in the third stage. And in the third stage, I'm seeing a right triangle.
A right triangle is right there, and we see that this third stage would have started at 25 seconds and it ended at 60 seconds. So we need to find the distance during that third stage, and we also made mention that in order to find the distance during this third stage, we need to find the area under the right triangle or the area under the graph. That was a general statement. This case,
we're about the third.
The third.
Okay.
We are going to our final break. When we come back, we'll wrap things up.
Okay. Welcome back. Okay, so let's pick up where we left off when we went for the break. We were looking at calculating the distance traveled in the third stage.
Right, and if we examine the diagram carefully, we can see that during the third stage of the journey, there is the geometric shape that's there is a right angled triangle.
All right.
And because of that, we need to find the area, and I'm going to be using the formula half base
Times height.
multiplied by the height, right? Some persons also represent this as base times the height divided by 2.
Yes.
Now, can you identify the height and the base that's there?
Okay, so based on what I'm seeing, the height would be on this y-axis, 12.
So it's 12 in this case, right?
Yes. And the base for that third stage would be 60 subtract 25.
And why are we doing that?
Because we're focusing on that period of time, as the third stage is from 25 seconds to 60 seconds.
Good. So 25, we're subtracting 25 from 60, and that will leave us with 35,
Awesome.
right?
Yes.
Okay, and a half of 12 is 6,
Six.
and we can multiply that by 35 and get a final answer of 6 is 18.
210
210, and the unit in this case would be meters.
as the distance traveled.
So the distance traveled during the third stage would be 210 meters.
All right.
Now we're going to be looking at another question, right?
Okay. All right. So I'm seeing that we have a distance time graph. The one before was a speed time graph. This one is a distance time graph, which describes the journey of a train between two stations, A and B. Now, for how many minutes was the train at rest at B? And B can be found on the y-axis between 80 and 120. And notice on this graph, time is still on the x-axis. However, now we have distance on the y-axis as we're looking at a distance time graph. So based on, it asks for how many minutes was the train at rest at B. All right, so notice at B, that would be 20 minutes. Because looking at the measurement on the y-axis, we notice that we're increasing by 20 at each interval. So at B would be 100. So 80 to 100 would be 20 minutes.
Or we could look at it to say that identify B on the graph, we move across horizontally.
Yes.
And then we see it starts at 40 seconds and ends at 60 ends at 60 minutes. So if we do the subtraction right there, it would be 60, or ending, subtracting our starting point, and that will also give us 20 minutes.
Right.
Now the next question is for us to determine the average speed of the train in kilometers per hour on its journey from A to B. So we need to find the average speed. Nikisha, how do I go about finding the average speed?
Use it by triangle.
All right. So the direction shows acceleration, right?
Yes.
So it would be the velocity.
Divided by time.
Are we given the time?
Yes.
We can get the time, right? And we need to find the velocity.
Okay. So, right. So that would be...
No, we are finding, yeah. That would be
distance divided by time. Okay, yes, because it's average speed that we're
Average
looking at,
speed,
not
I'm sorry.
acceleration.
Average speed. And we use our triangle.
Yes. All right, so the distance here would be 100. The total distance traveled from A to B would be 100, where B is on the y-axis. And the time covered during that time would be 40 minutes.
Yes.
So,
now the time is in minutes and not in hours.
okay.
How do I go about dealing with that aspect of it? I see on the board you would have represented it to say it's a 40 minutes is a fraction of the whole 60 minutes.
Yes.
And that works. So it would be a distance of 100 kilometers divided by 40 minutes,
Yes.
which is a fraction of the hour, 60. And what applies when we are actually dividing?
All right, when we're dividing, we usually invert, get the reciprocal of the divisor.
Right. And when we reduce or simplify, when we simplify this, it would be, go to the summary.
All right. Okay. That's all.
That's all for today. Class time resumes tomorrow at 9 a.m. with more CSEC mathematics. Until then, keep safe.
Hi there, I'm Simon Preston from TVJ. Thank you very much for watching our YouTube channel. To see our latest videos and also to see live events, click here. To see our full videos on onespotmedia.com, click here. Thank you very much for watching.